So Jesse, if this works, then we can go remote for the rest of the week.
Yeah, that's the game plan. So ultimately, at the end of the class today, we'll see what everyone's thoughts are, and then you'll always have the option if you want to go to the tech garden. But if you like to join remote for the rest of the week, you can do that. So I'll actually send a poll out at the end of the class just to see where everyone's at, and we'll go from there. That sounds good.
Cool.
Yeah, cool. Thank you.
Cool. Are you at
you
the
got it.
garden?
Me? No, I am home.
You are remote. Got it.
Are we
All
using the chat function on the side to ask questions tonight?
I'm sorry, can you, oh, you want to use the chat to ask questions?
Did we? I can hear today from home, everyone.
I mean, I think audio is fine, unless anybody has an issue with audio, but I think it's just simpler to use one modality, if we can stick to one modality, either audio or chat. It's just less to keep track of, less for me and for everybody else, I think.
Yeah, I was gonna say maybe we can leverage Slack too, just so that sort of stays if there is like particular links and whatnot. Just because I don't think that the Zoom chat like will actually get saved. So if you're doing like ping out links, for example, like Jake, if you want to share like repo links or if there's anything else, I'd say use that Slack channel, just because I don't think the Zoom chats will save here.
That sounds fine. Yeah, I have trouble getting notified either way. I'm not, sometimes it's hard to follow both of them, but anyway, yeah, as long as we choose one particular modality for asking questions, then and just stick to that, I think that would be okay. So
Cool.
So for tonight, let's try audio, and if we have issues, then we can switch over.
Also, Jake, we are live.
Yes.
So you are good to share a screen and all that stuff whenever you're ready.
Okay, super. Thanks, Jesse. So yeah, so I'm going to retake attendance because I think we have some more people who joined. Let's see, is Dana on? Okay, Dana not on yet. I think Jaquai joined. Sorry, is it Jaquai or Jackie? Are you on mute?
It's Jaquai.
Jaquai? Okay, thank you.
You're welcome.
Yeah. And is Tim on? Tim's not. Tim, yeah, I see Tim here. Tim, you on? Are you on mute? Well, I see his name here, but I can't hear you if you're on. If you can hear me, give me a sign. Just chat to me or raise your hand or any of the above. But we'll just proceed. And then was Anna here? I didn't see Anna. Okay, don't see Anna today. All right. Okay. So so let's get started. So I wanted to revisit yesterday's lesson a little bit because I had an idea about how to illustrate some of the aspects of error handling that I think might be helpful. In particular, so we were talking about error handling as control flow, and I thought it might be useful. You know, we talked about like different debugging techniques, and at the same time, I didn't fire up the debugger once during class, which is a real shame. So I thought let's fire up the debugger and let's walk through some of this code, in particular the lockbox example, so we can actually see what like how that code was flowing. So I just wanted to spend 5 minutes doing that, and then we'll proceed on to the main subject matter today, which was about regular expressions. So we've got our code here. And you may remember that we want to make sure that when we run this, we want to make sure that the box is locked after we call the with box unlocked function. So you can basically, so if you remember what we did was we called in our with box unlocked function, we called box dot unlock to unlock it. And then at the end of it, we called box.lock to lock it again. And then we called body to call the function. And let's see what happens. So let's set a breakpoint in here with the Chrome debugger. Oh, wait, the reason why I can't do that is because I actually have to edit the code in my editor and then reload the page. What am I thinking? Okay, so box.lock, box.unlock. Oh wait, I actually have that backwards. We want to unlock the box, then we want to lock the box, then we want to call body. Let's run this and set a breakpoint and see what happens. Okay. So we've hit the breakpoint, and now there are a couple of things which are important here. Under the scope, sorry, actually, the main thing that we want to take a look at here is this thing that's called the call stack, which shows where we are in the program. So we can see that it started here. This is higher up the stack, and now we're in here. And then if I step to the next line, so if I step here, now we're on body. I'm going to step into the call to body, and now we see we end up inside of this function, which we're passing in as an argument. And you can see it in the call stack right here. It says anonymous. We can click back up to go back up or down into the call stack. So we can actually see the functions that have been called, and it's like a stack of functions, like a stack of plates. So this was the function that was going to succeed. We can see that, okay, it finished, and now we're calling box.unlock, and then it returns from the with box unlocked function, and good, okay. So then it calls it again, and we call box.unlock, and then we go into body, and then it's going to throw the error, and now we can see what happened was now we're in the catch function outside of, in this try catch block, outside of the call to with box unlocked. So I'm going to do that one more time just to illustrate. So I'm going to reload the page. Okay, so we can see it's being called inside of this try function, this try block. Now we're in with box unlocked. Now we're inside of this body function. We can see the stack. We see we started here. Now we're in with box unlocked. And now we're in the body function. And if we, and basically, when this error gets thrown, it's going to go all the way back up the stack until it gets to the first catch block, the first catch block that it finds for this pair of try catch blocks. Or it's going to go all the way up to the top level to the browser, and the browser is going to handle it. So when we talk about try catch as control flow, that's how you can think about it. It's just going to take this whole stack of function calls, and it's going to dump you into the first catch block. So that's why if you want to handle, if you want to make sure that you're handling the exception locally in some special way, like making sure that the box gets relocked, you have to do it. You basically have to like intercept this call, this try catch block. You have to add a new one so that we end up in this box in the handling it locally. So anyway, I hope that maybe helps to clarify things a little bit. And if there are anybody has any questions about it, we can make time to talk more about it, either after class or maybe at the beginning of tomorrow's class. I want to make the beginnings of each classes set that up so that there's a little bit of time to ask about yesterday's class.
I just have a quick question.
Yeah, please.
Okay, so are we going to be doing the same thing tomorrow?
By same thing, do you mean, sorry, what do you mean?
The live chat. I mean, live classroom instead of being actually physically in the classroom.
Oh, I mean, I think you have the option to do it either way. I'm remote, so you can be remote too if you want. It's
Yeah, I was gonna say, you have the option. So at the end of class today, I'm gonna take a poll, and then whatever all this, all you want to do. So we can choose to do fully remote tomorrow and Thursday, or we can do, if you want to join in person in class, you can certainly do it that way as well. But I'll pull at the end of the class, and then we'll sort of make a decision, if that sounds good.
cool.
Okay.
Okay, so so nobody has any questions about exception handling at this moment. We can dive into the main subject matter of today. Does anybody have any questions before I move on? Okay, let's do this.
Can you hear me?
Oh yeah, I can hear you. Is that Dakir? Oh, I think you're on mute now.
Hello?
Hi, can you
Okay.
hear me?
Yeah. Can you explain the finally part of it?
Yeah.
Really?
Yeah, okay. So basically, finally is going to run no matter whether an exception gets thrown, okay? So we're calling this function twice, right? The first time we call it, the function that we're passing isn't going to throw an error. The second time we call it, the function that we pass is going to throw an error. Finally is going to execute no matter what. So again, let's run this code and step through it and see what's happening. Okay, so we've called it the first time. We go into body. It's not going to throw an error. And we still end up in finally. So we're always going to go into the finally block, regardless of whether an error gets thrown or not. The catch block you'll only go inside of the catch block if an error gets thrown. But finally, you're going to go inside of the finally block no matter whether an error gets thrown or not. So let's do the second function. Okay, second function. Unlock the box, call body. Okay, an error is thrown, but we still go into finally. So basically it means that the code that you're going to execute in finally is going to get executed regardless of whether an error is thrown inside of the try block. Does that make sense?
Yes. Thank you.
Okay, cool.
So,
Anybody? Yeah.
so finally doesn't prevent the error. It just makes it so that the function finishes rather whether there's an error or not.
Yeah. That's mostly correct. So technically the function is going to finish either way, but it guarantees that everything that's inside of inside of this block, by block I mean what's inside of these two squiggly brackets, is going to get executed regardless of whether an error is thrown. But like if I were to add some stuff outside of it, like if I were to add some do console.log hello world, then that actually won't get called when the error is thrown because it's not inside of the finally block. So okay, so this guy succeeds. Okay, we call box.lock. Good. I'm going to pull up the console here. Put this into view. And then hello world is called. Okay, so then we call it the second time. Then an error is thrown. And again, we get to call box.lock because it's inside of finally. But I don't think line 19 is going to execute. Yeah, it doesn't execute. The error just gets raised and propagated, and it gets caught and handled in this outside try catch block. Because again, the error propagates up through the call stack until it gets to the first try catch block that it finds. Or it goes all the way up to the browser and then the browser handles it. like if we didn't have that try catch block here, like I'll just get rid of it. It's going to go up to the browser. And we can see what that looks like. Okay, so that's what it looks like when the browser catches an error. It just dumps out to the console, and then we can inspect it in the console. See, this output shows you the call stack. It shows you where you were in the program when that error happened. So the top part is the deepest place. Oh no, sorry, the bottom part. Okay, I don't know whether it's the top or the bottom, which is the deepest part in the call stack, but it's one of those, and you can see where you were in the program. Basically, this shows you where you were in the program when an error happened. This is really, really useful for debugging your program, because like it used to be the case that you'd write programs like in C or C++, and like error handling in C and C++ is totally different, because you can have errors that there is no useful recovery information. You don't get a call stack. Maybe you get what's called a core dump. They can throw errors called segmentation faults, which is where you read or write memory that you don't have access to, and then your program just dies. It just quits, and you don't know anything about why that happened or how you got there. And maybe you can go back and inspect like just a big chunk of memory, like whatever was in memory, to see what might have happened later. But that's so that's how things used to be. But it's much safer and easier in JavaScript, because it's like a higher level language, and memory is protected in JavaScript, so you can't read or write it illegally in the same way you can with C. Does anybody have any other questions? Okay, cool. So let's move on. Today's lesson is one that I'm super excited about.
Hey, Jake.
Yeah.
Jake, sorry to cut you off. Just real quick. I'm dropping here, but just for all the students on the call and whatnot, don't hesitate to stop, ask questions. Obviously, Jake can't actually see you, so just make sure that if you do have a question, unmute your mics, just so that's you're not talking on mute. That's happened to me a lot of times.
Yeah.
So,
or
if you have any questions, certainly don't hesitate to reach out on the Slack as well here. But just make sure if you have a question, to make sure you're off of mute here. Yeah.
Or you could try to use the raise hand button in Zoom. I'm gonna pay more attention to that now that I know what it looks like. So either of those. Yeah.
Thanks, Jake. Appreciate it. All right, everyone.
Thank you.
Bye.
Bye. Okay, let's get started. So today we're talking about regular expressions. I'm super excited to talk about this because I kind of love regular expressions. There's actually a lot of interesting sort of computer science researchy topics around it, which we're maybe going to touch on a little bit today. But yeah, this is going to be, first dive into regular expressions. So what are regular expressions? So I really like this webcomic by Randall Munroe as a way to explain what regular expressions are useful for. So basically, he says, whenever I learn a new skill, I concoct an elaborate fantasy scenario where it lets me save the day. And then they need to search through 200 megabytes of emails to look like something formatted like an address. And then he swings in on a rope and writes some regular expression code to find the thing that looks like an address. And that's kind of a funny example of like what regular expressions are useful for. So yeah, basically a regular expression is is like a little mini language that's embedded inside of most programming languages. Usually it's available as a library, which you have to import into the language, into your program. But in JavaScript, they're actually built in. There's like a native syntax for creating regular expressions. Again, that's one of the interesting historical features of the language, is it has this built-in syntax for creating regular expressions. The syntax for declaring a regular expression is a little bit cryptic, but you'll see that once you get the hang of it, it's not too difficult. So I think I need to move this window over so I can see my slides. So an example of a regular expression. So there are two ways to create a regular expression in JavaScript. There's this first syntax where you use the new operator. You say new regexp, and then you create a string, and you declare your regexp inside of the string. And then there's the second notation, which uses these forward slashes. So you say forward slash, and then you just write the regexp, and then you have another forward slash, and that ends it. There are some nice features about using the second syntax, which is that you don't need to escape the backslash character. So like if you're declaring a string and you want to put a backslash into the string, then you need to use two backslashes in order to get the backslash into the string, because the backslash is used to escape the next character. But with when you're using the second syntax there with the forward slashes, you don't actually need to escape the backslash. You can just put the backslash right in there, and it knows what to do with it. We'll just do a quick example of how you use a regular expression. Let's go into the REPL.it. I think we're going to use the same session as yesterday. I think I need to reboot it though. Okay, start new session. Invite others to collaborate. Copy to clipboard. I'm going to put this in the Slack under CIC students. There you go. And if you guys want to join, well, I love how easy that works. Okay, and we're just gonna paste some code in here, run it, see what happens. Okay, so we can see that here we've declared a regular expression, and then we're testing something, and that something that we're testing is a string. Basically, we're saying, is this pattern present?
Here because I'm in class.
Okay, all right, okay.
Say, is this pattern present inside of this string? And you can see the first one, this test function returns true because the pattern ABC is in the string ABCDE. And then the second one returns false because the pattern ABC is not in the string ABXDE. So that seems, this seems pretty simple, straightforward. But it gets more interesting what you can do. So you can declare sets of characters. So basically, you've got this square bracket notation, and that means that everything inside of these square brackets, you're going to look for exactly one of those things. It means I'm going to look for 0 or 1 or 2 or 3 or 4 or 5, 6, 7, 8, 9. And I'm going to look for exactly one of those. And if I find exactly one of those, then I'm going to return true. So it was able to find basically a digit. This means look for a digit in the string 1992. Because 1, 9, 9, 1 and 9 and 9 and 2 are all digits that are in this set of characters. There's a way to do this a little more concisely, which is to use a dash in between two characters. So then it will basically look for like a range of characters. So this means look for one character, like look for, I mean, basically this means the same as this. Like it means look for a digit, 0 through 9. All the characters between 0 and 9 are in this set of characters that we can match on. So there's another way to declare this idea that we want to.
Jay, can I ask a question?
Yes, please. Oh, sorry, I can't hear you.
I keep forgetting. I got the space thing going on.
Okay.
So inside those forward slashes,
Yeah.
that's the expression that we're looking for. That's the expression that we're doing the looking inside of.
That's right.
And then the 1992 was what we were looking for.
Oh, no. Sorry, it's the it's backwards.
Oh.
So yeah, so the slashes are the pattern that we're looking for, and the in 1992 is what we are looking inside of. To yeah, okay. We're basically saying test this string to make sure it has this pattern.
And the dot test is like a keyword for this whole thing?
Yeah, it's a method on the regular expression object.
Oh, okay.
Yep. Yeah, exactly. So yeah, for sure. I mean, so we can put this inside of a, say let re equals this guy and then do re.test. And it's because this re is like basically by doing this, we're creating an instance of a regular expression. And then this re is a regular expression object, and test is a method on that regular expression object. And that returns true or false. So there's a way to more concisely declare certain special sets that are commonly used, so you don't have to use the range character and type 0 through 9. And so there's a special syntax for these shortcuts. And here are some examples of them. Basically, you can say like backslash lowercase d means any digit character, backslash lowercase w means any alphanumeric character. So that's basically A through Z, like lowercase a through Z, capital A through Z, and 0 through 9, I think is everything in /w. /s is any white space character, which means space, tab, new line. Backslash uppercase D means anything that's not a digit. Backslash uppercase W means anything that's not an alphanumeric character. And backslash S means anything that's not white space. And then there's this one special character, which is just the dot, which means match anything except for a new line. So anything except for a new line character.
Could we back up a little bit? I'm sorry, but
yeah.
For me, it's really helpful if I could understand like when this is used. Is this used on the front end or the back end, or like
both?
What is this? Okay.
Yeah. I mean, so the example. So I only gave you one example, which is this kind of funny example. But like this is kind of how it's used. I mean, like email, like validating email addresses.
Right.
If you look at the regular expression for validating an email address, actually, let's just look it up right now. There's a stack. There's definitely a Stack Overflow post on it. Okay. And you will let's just take a look at this thing. Stack Overflow, regex for validating email. Okay. So who thinks it's going to be like very simple? Who thinks it's going to be? Who thinks nothing simple?
Not me.
So I feel like that's a trick question.
I mean, it's terrible, basically. So here's what it is, right? And like, who could even read that or understand it? Anyway, but it's actually a very concise method. Like, it's a very concise language for expressing this particular concept. Like, how do I know that this thing is a valid email address? You know, like if you were to try to write this code just procedurally by hand using any programming language you want, JavaScript, like whatever, and you were to try to write a program to replicate this logic, it would be like 1,000 lines long, you know? But here, it's a very condensed way of capturing that particular logic. I want to take this string and match it against some pattern. This is the way that people like to do it. And it's useful for a large set of problems. There's also a large set of problems that it's not useful for. I can post a link in the Slack after for a book that does a really good job of describing the, like, basically where regular expressions, like the limits of regular expressions, like from a formal computer science perspective. Really good book. I'll post it in the Slack later.
Okay, that would be cool.
Yeah. So anyway, but this is an example of where it's useful. So it's, you know, there's some pattern, you want to match it. We use this weird, funny language to declare these patterns and then match them. And it's used in the front end and the back end, you know. In fact, that's kind of one reason why it's useful to use JavaScript for both the front end and the back end, is because you can actually share this code, because this type of problem of like validating user input is something that you have to do in both the front end and the back end. So like, if you remember the Little Bobby Tables webcomic that I posted last night, that's kind of an example of, like, you want to make sure at all tiers of your application that you're not accepting either malformed or potentially malicious user input and passing it all the way through your application. You want to check in the front end, you want to check in the back end at your application level. And ideally, you want to be able to reuse that logic at each tier.
Okay. So is this how you would also match up passwords to see if they're correct?
Yeah. Yeah, you could use it. You could use it for that. Yeah. There's a whole bunch of stuff that they're useful for. Basically, they stop being useful once you want to actually write, like, once you actually want to, like, write a parser to parse a programming language, you know? So let's say you're, like, actually building a version of JavaScript, or like a program that takes, like, an HTML document and tries to, like, turn it into, you know, a DOM, like a tree, like a data structure that you can render, something like that. That is where regular expressions start to, that's sort of the limit of regular expressions. They don't really have enough. It's too limited of a language to express those concepts. But but for a variety of simple pattern matching tasks, it's a very simple, concise powerful language for doing that work, and it's used a lot, maybe too much.
Okay. Yeah,
good question. So yeah, let's keep doing it. So yeah, we did. We were doing sets of characters, right? So we've got these special sets of characters: digit, alphanumeric, white space. There are more, and so that lets you. So this is an example of like if you wanted to match a specific kind of a date format where you have like month dash day dash year space 24-hour notation hour colon minute. You could declare it with something like this. So this is like, so again, this \d means anything that's a digit, 0 through 9. So this is saying, look for a digit, and then another digit, and then a dash, and then a digit, and then another digit, and then a dash, then 4 digits in a row, then a space, and then 2 digits, and then a colon, and then 2 digits. And then we can test this, see how it works. Okay. So yeah, so we can see for the first example, it returns true. And the second example, where we're trying to give it a month written out is in letters, is alpha characters. It returns false because it doesn't match. So and there's a more concise way of writing this expression, which we're going to talk about in a minute. So another way of working with sets of characters is you can use the caret symbol, which basically lets you invert the set. So that means that anything that's not in the set gets matched. So for example, not binary would be caret 0, 1. So anything that's not a 0 and a 1 gets a match. So you can see here, for example, this string is all binary code, 101110. And this string has a 2 in it, which is not in the set of 0 or 1. So that means that it will match that number 2. You can also see here that this test function is looking through the whole string to try to find a match. It goes through every character until it finds some sequence that it thinks is a match. So now we get to some more. Yeah.
With that last one, it's looking for something. It's looking for anything that's not a 0 or a 1.
That's correct.
Okay.
Yeah. So it basically goes through this thing and says, okay, is this a 1? Or sorry, is this not a 0 or 1? Not a 0 or 1? Not a 0 or 1? And it keeps going until it finds this thing that says, oh, this is not a 0 or 1. It's a 2. And then it matches that and returns true, succeeds. So then okay, so that's it for declaring character sets. Now we're going to move on to some more stuff that you can do with regular expressions, which is repeating things, repeating parts of a pattern.
Question again.
Yeah.
For the set of character, that is the I'm sorry, I can't speak today, but for set of character, you're just using it. It's more like a true or false statement. It's not. It doesn't work like indexing, like looking into a string to find a character. Like, I mean, you can't do any of that, right?
Well, the test method only returns true or false.
Okay.
but there are other methods on the regular expression and also on the string, which will allow you to get more information out, like where it found the match. So we're gonna talk about that in a bit. So repeating parts of the pattern. So you can so these characters have a special meaning in a regular expression: plus, star, question mark, open squiggly bracket, and then some number, and then close squiggly bracket, open squiggly bracket, some number, comma, some other number, close squiggly bracket, and then open squiggly bracket, some number, comma, and then close squiggly bracket. And these all are basically ways of saying that something is going to repeat some number of times. So what that means is that with the plus, it means you're gonna see this sequence one or more times. With the star, it means 0 or more times. So it'll match if that part of the pattern doesn't even show up. But it could appear any number of times. The question mark means optional. So it'll match if it doesn't show up or if it shows up exactly once, but not if it shows up more than that. And the n means it's going to appear exactly that number of times, where n is any number. So if you put open squiggly bracket 3, close squiggly bracket, it means it's going to show up 3 times. And then the squiggly bracket nm syntax means it's going to appear at least n times and at most m times. So it's any amount between that number, n and m. And then open squiggly bracket n means it's going to appear at least n times. So it could it will appear at a minimum n times, but it could be more. So we're going to go through a lot of examples of what all this means. Okay, so so you can see some examples here. So again, \d means it's a digit. So we're looking for a certain number of digits. So if you have \d plus, does anybody remember what plus means? Just dive in.
1 or more. Correct.
Yeah. So it's going to return true here because we have 3 digits and it needs 1 or more digits. But this one is going to return false because it needs at least 1 digit, but there is 0 digits. And for \d star, so does anybody remember what star means?
Appears 0 or more times.
Correct. So so for that one, it's going to return true for 1, 2, 3 because it's 0 or more. Because 3 is more than 0. But for the last one, \d star, it's also going to return true because there were 0 digits, and so it matched. So this gets really interesting. Well, I guess we have a couple more examples here. I'm so excited, I just want to jump ahead. Okay, so we'll just dive right through the other examples. So yeah, so the question mark means, anybody else remember what question mark means?
Optional appears 0 or 1 times.
Correct. Yeah. So so this is an example of, like, you know, in Canada and the UK, they spell neighbor with a U. It's an anglicization. So if you want to check for the word neighbor, you might make the U optional. So both of these strings will match this particular pattern because this guy has the U, this guy doesn't have the U is optional. For the next one, so this is an example of this kind of range. So basically, you remember squiggly bracket 1, 2 means that you're looking for at least 1 digit and at most 2 digits. So so this is this is the more concise way of expressing that previous slide, that previous example with this one. Yeah. So instead of having to write \d all of these times, like this is pretty difficult to read, is pretty verbose. So a more elegant way of writing that same expression is to use these special range characters. So this means we want at least 1 digit for the month and at most 2 digits for the month. Likewise, at most 1 digit for the day and at most 2 digits for the day. And we want exactly 4 digits for the year, because this is assuming that we're, you know, at least in modern times and not before the year 1000. We want at least 1 digit for the hours and at most 2 digits for the hours, because I guess it's not, you know, even if you're using European time, like 24-hour time, it still might be 8 a.m. So you only want 1 digit for the hour, and then you always want 2 digits for the minutes. And that gives you a concise way of matching these particular kinds of date strings. Okay, so now it gets really fun. So now it's about grouping.
Can I just interrupt you here for 1 second on
Please.
the date time thing, since
Yeah.
Europeans invert month and date?
Well, that's
Deal with
true.
that? Yeah, we don't deal with that.
Not in this case.
Okay.
But I guess if you did, I don't know. I mean, that sounds like a neat exercise, right? Maybe we should just. Actually, no. I'll save that for later.
You're gonna assign it, and then everybody's gonna hate me for asking that question.
Well, I mean, we'll. I just need to make a note of it. So.
Yes, note to come back later.
Yeah. Come back to this.
Mhm.
Invert dates to deal with European dates. Okay, cool. So so grouping. All right. So this is where these repetition operators become really useful, because you can take your regular expression and you can separate it into groups, and you can add these repetition operators to the groups, so that only particular groups of the regular expression get repeated. So if you read this guy, basically what it's doing is it's saying, okay, I'm looking for a pattern like that has 1 B, 1 O, and then 1 or more O's, and then 1. Okay, well, then it gets interesting, because we have a parenthesis. So the parentheses allow us to create a group, and we can put these operators, we can attach them to the group and then also to characters inside of the group. So what's happening here is inside of the group, we say we're looking for a pattern like H, O, and then any number of O's. And then this whole pattern can be repeated. So we can look for H, O, 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 and then it can start over again and do H, O, O, O. But we can't just have boo. We need to have at least 1 who. But we can have any number of who's, but there needs to be at least 1 for it to match. So here, is an example of that. Boo, who. But if I just did boo, it wouldn't pass. Let's give it a try. Okay, run that guy. Okay, it passes. But if I take this guy out, okay, it doesn't pass. And likewise, if I just did, HO, that wouldn't work either. But if I do at least 1 other O, then it works. So this is a pretty powerful.
Clarify that
Yes.
the plus sign attaches itself to that last character. Just so if that O was a T instead, we could have any given number of T's.
Correct.
Okay.
Yep. The plus sign attaches itself to the thing that's to the left of it.
To the left of it. Okay.
Yeah. So the matches do a little bit more. They're useful for a little bit more than just allowing you to repeat things. They can actually be useful for allowing you to extract information from the string. So this is to go back to the question that was asked previously, asked earlier, about whether regular expressions only return a Boolean value, true or false, or whether they tell you where in the string it matches. So you can use parentheses, these grouping expressions for that as well, and I'll show you how to do that now. So in addition to the test method, the regular expression also has a method called exec, which stands for execute, and that will return another object called a match object, and the match object gives you some more information about what it found, like the exact string that it matched, like the pattern that it matched, and where in the string it was able to find that match. So for example, here, this regular expression says look for one or more digits. And so it scans through this string and says, this is not a digit, this is not a digit, not a digit, not a digit. Oh, I found a digit, one digit. Okay, that's a match. Oh, I found another digit, add that to the match. Oh, I found another digit, add that to the match. Oh, I'm at the end. And then, so it captures all of everything that it found, and then it returns the pattern that it matched. It actually returns it as an object which is like an array. So the first element of that array is basically the whole expression that it found. And I'll talk more in just a second about why it gives you an array and not just a string. And then the match also has an index property, which tells you where in the string it was able to find that pattern. So here it returned an 8. So and it's 0 based. So you go 1, 2, 3, 4, 5, 6, 7, 8, and that's where it starts the match. So yeah. So but this becomes really useful when you start to use it in conjunction with groups using parentheses. So in this expression, in this regular expression, oh yeah, okay. So there's another way to. I jumped ahead again. Okay, so there's another way to match a string. So instead of calling the exec method on a regular expression, you can also call the match method on a string and pass it a regular expression as an argument. And I think this is a much nicer syntax, like it reads nicer. It says, okay, I have this string here. Now I want to match against this pattern, because the other way is kind of backwards. It's like, I have this pattern and I want to execute it on a string. Like it just doesn't read as nicely. So most of the time, this is how you're probably going to work with regular expressions in JavaScript. So you're going to go string.match. So So, but yeah, the matches become really useful when you use them in conjunction with these grouping expressions. So an example of that is you can create a subgroup inside of the regular expression. So for example, what's happening here, I mean, this is not a great example, actually. Let's go to the next example. Yeah, this is better. Okay. Yeah, okay, this is a better example. So, sorry, I don't love these examples. I'm just going to take this one and then we're going to work with this. Okay. Okay. So so we have this regular expression, which is basically the word bad, and then optionally, you know, it could be written badly. So the ly is optional here. And so that means that it could either match the word bad or it can match the word badly. But because we have this grouping expression, remember how I said that the match object is an array of strings? The reason why it's an array is because of the grouping expressions. So the way that it works is each element of the array after the first element. So the first element matches the whole regular expression match, but every element of the array after that, you basically count the open parentheses of the groups, and for every open group parenthesis, that is a element that corresponds to the index of the element of the match array, which will contain the matched string. So that's a lot of words. It probably just makes sense to like take a look at what is being returned here. Okay, so so we can see here that what gets returned is a string called bad, which is the whole string that got matched, and undefined. It's undefined because we didn't have anything that matched this group. There was no ly, so it didn't get matched. But if I add ly here, what do you think that first element is going to be? Like the element at index 1 of the return match.
It's going to be badly?
It's not. That's a good guess.
Just ly or L?
Exactly, just ly. Yeah. So badly and then ly. And that's because we've created a group to contain that particular part of the matched expression. And if I create another expression, if I create another match group just for the y, then what do you think the match array is going to contain?
So is it going to be bad L, and then badly?
That is also that's a good attempt. So in fact, what it's going to be is it's going to be the whole match, which is badly. So
Okay.
0 always contains the whole match.
Okay.
And then after that, it contains so you basically can see where the parentheses start and stop. So because the second parenthesis is after the y, then that means that you know this whole thing, the ly, is that group, is the group at index 1. And then the group at index 2 is this pattern right here.
So I just had it kind of backwards as far as the order.
Yeah.
Okay.
Now, alternatively, if I set up the grouping expressions like this, what do you think the match array is going to contain?
So now, since you don't have those outer parentheses, it should go from left to right.
Yeah. So what do you think? So what would be at index 0?
Okay, so at index 0, would it be badly?
Yes.
Okay, so it's always what's after the dot. So it'll do badly, and then L.
Yep, that's correct.
And then Y.
Correct. Yeah. Very nice.
Yeah. Okay, I got it.
So previously you had it like sub-indexed, like when you had the Y inside the contained inside the L parentheses.
Yes.
You get back to what you had.
Here you go. Yeah.
Yes, okay. So you had parentheses. You had the Y by itself, and then you had parentheses outside of that to
exactly. So right. those are called nested groups. You can create groups inside of groups, and so you can start to see how you can create like rather complex expressions, because I can create this like, nested group, and then I can add, these quantifier operators to it. So that means that we need at least, so this means that we need at least one or more ly, so this should still match. But this also means that we can do ly, ly, ly. And it also means that we can do ly, y, 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 like that. And yeah, that's so you can do pretty complex things just with these, by composing these simple concepts together.
What's the purpose of this?
So the purpose is to, again, to go back to that example, it's for matching things that are, useful. There's sort of a large class of, you could think of them as being like mini languages. There's kind of a large class of sort of simple languages that you can, that's important to validate, or that you want to extract information from, that allow you to express very, that you can create patterns to match those things very concisely. So like this example is how you match an email address, which is like surprisingly complex. If we have time at the end of class, maybe we can try to go through this and see what the heck this thing is actually doing. But it is probably the most concise way to actually take a string and see if it contains an email address.
Jake, why did it say index 0 on your REPL?
Yeah, that's a good question. It's because the match object is not really an array. It's this like special object, which is kind of like an array, but it has other properties. And one of the properties is the index property. And the index property indicates where in the string it found the match. So because it found the match starting at the very first character, it shows that the index is 0. But if I add, foo bar bat at the beginning of it, then the index is going to be 9 because it's found the match 9 characters in. It's a good question. Okay.
Make that an array. It was that match.
Sorry?
I said, how did you make that an array?
Oh, so the match object is something which is array-like. It's not actually an array, but it's kind of like an array. It has array-like indices, like 0, 1, 2, 3, but it has other properties as well, like the index property. So it's kind of a weird it's another one of those sort of weird things about JavaScript that, you know, the match object is, there are a lot of things in JavaScript that are what you call array-like, which is to say they have like indices and they have a length property, but they're not actually technically an array. In fact, this was such a big problem, like figuring out if something, whether or not something was an array, that like I think in ECMAScript 5, they actually added a special array.isArray operator static function just to see if whether or not something is an array or not. So like, let's actually see what happens if we call array.isArray on this guy. I'm thinking that the answer is going to be no. Technically, it's not an array. Oh, well, I guess it's an array. So, but it's an array with some other properties on it. Yeah. But there are other things in JavaScript which are not actually arrays, but they're almost arrays. And that's confusing, but what can you do? It's JavaScript.
I'm sorry, why does it always say undefined?
Oh, that's because console.log doesn't have a return value.
Oh, okay.
Yeah, console.log always returns undefined, so it just prints that out to the console.
Okay.
Yeah, if I did 1 + 1, then I think it will return 2. So I think it's just showing, like, I think when it executes the program, it takes the last thing that was executed and shows you the return value over on the right here. Yeah, that's another good question. Yeah, okay, so yeah, okay, so there's one last thing that you should know about regular expressions, or how to make regular expressions, and then we're going to get on to like the really exciting stuff. Let me see. And I think we're getting, well, there's definitely a little bit more content. I'm going to try to push through so that we can wrap up the slide content by 7 o'clock, so that we can, you know, take a break and then have a good amount of time to actually, you know, practice writing regular expressions. So I'm going to try to blast through on that. Okay, so right, so choice patterns. So choice patterns, basically, it means that you have a choice between these different patterns. So you use the pipe symbol, which is, you know, the straight line symbol, and it allows you to basically choose between pig, cow, chicken, and then it basically says, you know, do I have like some pigs? Yes. Do I have a pig and chickens? And it says no, because you have to choose between the pig, the cow, or the chicken. So this brings us to a good place to talk about like what is actually happening inside of the regular expression. Like, what is it actually doing, and how should we think about it? And the nice thing is that regular expressions actually have this really, this alternative representation. And that representation is called a finite state machine, which again is a lot of words, but you can basically think about it like these railroad diagrams is sometimes what they're called. They're these flow diagrams. So like the previous expression, the previous regular expression, where you're looking for some number of digits and then either a pig, a cow, or a chicken, and then either an S or not an S, and then that's the end of the expression, can be represented graphically like this kind of a diagram. And you can kind of like intuitively understand what it's doing, right? It's like you start over here on the left, and then it looks for a boundary character, which basically just means like the start of a word. And then any number of digits. So you're kind of flowing from left to right along these black lines here. So any number of digits means that like you can actually loop, you're actually, you know, it has a little loop here. So any number of digits means you just look for a digit, and then you go back here, and you look for a digit, you go back here. You're just looping in here. And then it looks for a space, and then either one pig, cow, or chicken. So it's going to go into one of these, and then maybe it looks for an S, or maybe not. So if it finds an S, then it goes into S. But if it doesn't find an S, it just skips over it. And then it looks for another boundary character, again, which is basically like the end of a word. And then you're over on the right, and you're done. And then you've matched the expression. And when you're done, it takes that match and it returns it. So this is a really nice way to think about regular expressions, especially if you're working with really complex ones. And in fact, if you remember under this Stack Overflow post about the email address, it actually has one of these railroad diagrams, which will help us understand it quite a bit when we return to this later, which I hope we'll have time to do. I'm going to skip this part on backtracking. So to generate these railroad diagrams, you can use this online tool called DebugX. And I'm going to post that into the Slack channel. And I think we will probably make use of this later. Yeah, so you can play around with that. I think we'll play around with it together in a bit. So there are a couple of other useful things that you can do with regular expressions. So the first one is that you can actually replace parts of a string using a regular expression. So strings have this replace method, which allows you to, so for example, you give it, so the replace method takes two arguments. The first argument is the pattern that you're looking for, and then the second argument is what you are going to replace it with. So, and you can either give these parameters a string or a regular expression. So for the first parameter, so for example here, you're replacing all of the P's in the word papa with the word with the letter M. Although it's only going to replace the first one that it finds. It's not going to replace all of them when you use a string. So you're going to end up with the word mappa, which is not a real word. The way to overcome this is you want to give, you need to use a regular expression in the first argument, and then regular expressions allow you to add a little trailing G character at the end of it, which basically means don't just choose the first match. I want to run this on the whole string and run it on everything that I find that's a match. So like, for example, let's take this example, go to REPL. Run it, okay, gives us mappa, fine. Actually, we don't even need to use console.log for this, now that you mentioned it. Yeah, okay, that's much better. All right. So we just replaced this P with a regular expression and give it this global modifier. Then we run it again, we get mama. And that's because it didn't just run, it didn't stop after the first match. It continued and ran it on the entire string. And that's what the global modifier does. The other thing that we can do is we can refer to matched groups. So the replace method lets you basically write a $sign and then a number, and that refers to the number of the group. So basically, it's the same idea as with the array indices, how the array indices are of the match object are ordered by the order in which the parentheses appear. So this is match group number 1, and this is match group number 2. You can the replace method uses that same concept in order to allow you to refer to those match groups. So, for example, what this is doing is it's looking for one or more alphanumeric characters, and then a comma, and then one or more alphanumeric characters, and then it's got the G, so it's going to run this on the entire string and look for all the matches that it can. And so this is the pattern that it's looking for and trying to replace. And then it's going to replace that with a string, and that string is going to be composed of the second match group followed by the first match group. So it's basically, so the idea is that if you have a list and that list is composed of names where the last name is followed by the first name, it's like last name comma first name, and you want to replace that with first name space last name, this is a way that you can achieve that. Let's just do that right now. Did it work? I think it did not. Oh, no. It actually did. Yeah, it totally did. Yeah. Barbara, it just didn't look like it because of the new line characters. Let's do console.log actually. Okay, great. So, this is also a pretty common thing that you'll do from time to time in JavaScript. Oh yeah.
What were you referring to in the last slide? What was the W referring to?
Right. W is one of those. So again, that's a special set character, and it refers to alphanumeric.
Alphanumeric. Okay.
Yeah. So 0 through 9, lowercase a through lowercase z, uppercase A through uppercase C.
Okay.
Yep.
Okay.
So the replace method also allows you to specify a function that basically receives the matched string and does some work to it. So for example, this is looking for references to the FBI or the CIA that are lowercase, and then it receives that string and it converts them to uppercase when it finds them. And just see here, run this guy. Yeah, so it converts to CIA and FBI. Yeah, you can do more complex things with it. Like here, it's taking a string, finding all the occurrences of a number followed by an alphanumeric word, returning a string in which every such occurrence is decremented by 1. So like, you can, if you want to, look for a number and a word, and then decrease the number and change the word so that if it has an S, it removes the S, and you can do all of that with the string.replace by putting, like this whole function here, this -1 function is doing that work of taking the matched number, which is a string, and converting it to a number, and then decrementing it, which means subtracting by 1, so that you have a new number, and checking to see if that number is 1. And if the number is 1, then you remove the S from the matched matched unit. from the second match group. And then if it's the amount is 0, then you just add the word no. So it says no lemon, 1 cabbage, 100 eggs. And this was the original 1 lemon, 2 cabbages, 101 eggs. So you could do these things if you wanted to. So just to return to the other syntax for declaring regular expressions, sometimes you actually want to use it, and those times are when you need to dynamically create a regular expression. So by dynamically, what that means is you have received some data in your program, and you want to incorporate that data in the pattern that you're looking for. An example here, so you can't do it with the /base notation because you can't use any variables in that. So you have to basically construct a string for that regular expression, and then use the new regexp. You have to instantiate a new regular expression using the regexp constructor. So you can see an example here of when you might want to do this. So you've received some data, which is the name of a character named Harry. And then there's some text that you want to match on. And you want to look for that name, Harry. Additionally, you don't care about the case. The match needs to be case insensitive. So that's another modifier. So just like you were able to use the G to look for global matches, you can also add I, which stands for case insensitive matches. So that means that it will match the letters H-A-R-R-Y, but it doesn't care if it's uppercase or lowercase. So you can see here, it's creating a new string, and you gotta use double backslashes, because in JavaScript you have to use double backslashes in the string to get a single backslash, because again, backslash is the escape character. And then, so this is how you declare a word boundary. And then and then the parentheses, of course, for grouping. And then you can see you're concatenating the strings together, and you're referencing this variable, this name variable, which is the data that's been passed into your program. So you're concatenating this string with this variable, which is a string, with this last string, and then that whole thing is getting passed into the regexp constructor function to create a new regular expression. And then you can use that regular expression as you would any other regular expression. So here it's being used to replace any reference to Harry with it's used to wrap it in underscores, in underscore characters. So there are some things that you should be aware of when you're using this technique. One of those is that you will probably need to replace any kind of special characters. Sorry, excuse me, I might need to sneeze. Hang on. I'm okay. Okay. You might need to replace any kind of special characters that are in the string that are significant with regard to the regular expression. So that includes, if the name that you're given is something like this leet speak kind of name, like Death Lord, where it's using a plus sign for the T and angle brackets for the O, you would need to sanitize that input in order to actually match that name when you're passing it to the regular expression constructor. That's just something that you should be aware of. So you can see here it's looking for all the special characters that are significant to a regular expression. And then it's replacing that with a backslash version. It's basically escaping it by adding a backslash in front of it. And and then the last thing that you should be aware of is that a very common pattern when you're writing programs that use regular expressions is to loop over the matches. So this is called writing a scanner, and a scanner basically runs through your the code and loops over your text looking for matches, and it just continually runs. So this is a little example of a program that is helpful for doing something like that. This is a pattern that you can use. So you're given some input, and then you have your regular expression pattern that you're matching. And then you declare the variable, the match variable. And you can say while match equals, and then you run the regular expression to get the match out. And then you can log the result. And the reason why this works is because if a match cannot be found, this works for two reasons. The first one is that the regular expression actually has some state in it. And what that means is that it remembers the position that it was at the last time it ran. So it goes up to a particular index. So it finds a match, runs through that match, gets to the end of that match, and then returns that match. And then when you run exec again, it continues from the place that it was at and runs until it finds a match and gets to the end of that match, and then it returns that match again right here. And it just keeps doing that over and over again, just continually scanning through the program a little bit at a time, returning each match that it finds until it gets to the end, and then it returns null. And because in JavaScript, null is what's called a falsy value. It's not Boolean false, but if you put a null, if the expression contained inside of the an if statement or a while loop, or anything that's checking whether a value is true or false, if it finds a null, then it interprets that as false. And other values that are falsy like that include the number 0, undefined, and the empty string. So that's an important concept to know about. I think everything else is considered truthy in JavaScript. So anyway, this is how you write a scanner. That might be something that you will need to do at some point. So that is the end of the lecture content. Here's a summary for your reference. The slides are available online, so you can reference that. And actually, there are a lot of JavaScript references out there for regular expressions. So I'll drop one in the chat that you can refer to. So let's break for about 15 minutes and then come back and we'll do some exercises. Unless anybody has any questions right now.
Jaquay has a question in the chat box.
Oh, in Slack or in the
Zoom group chat.
Zoom group chat. Okay, I have to remind myself how
it's not really a big deal, but not a number is falsy, right?
Oh yeah, that's true. That's also, yeah, I forgot about that one. Yeah.
I just wanted to make him aware that there might be some text in there.
Thanks. I don't seem to get a notification whenever anybody types in there, and I'm not actually.
Yeah.
Not really. Oh wait, I see.
I actually wanted to go to break.
It lit up orange at the bottom of my screen where it says chat. And it had her name on it, so.
Yeah, I think you're right. I think it comes up under more for me. So I've seen that bar pull up a couple of times,
Yeah.
but I didn't know what it meant.
Oh.
Okay, now I know. Okay, cool. All right, great. So yeah, let's break and let's reconvene at about 7:15 or 7:20. Let's do. We're running a little bit late, so if you guys don't mind, let's do 7:15. Does that work? Okay.
Yeah, that's fine.
Okay, super. All right, thanks very much. Talk to you in a minute.
All right.
Bye.
Okay. I'm gonna move to a new location right now. I'm gonna leave the meeting for a bit. Nobody's listening. Okay.
I'm listening, Anna. You said you're moving to a new location.
Yeah.
Okay.
If I'm not here by the time he comes back, can somebody just pass that message along?
Yeah. These are being recorded anyway, so if we miss anything, we can always go back, right?
Yeah, I think it's streaming on YouTube right now. So. But I want to be able to follow along so I can ask questions.
Yeah. Okay. Yeah, well, he'll be back at 7:15. I'll let him know.
Okay, thank you.
All right. Okay. Yeah, and if I forget, I'll type a message in the chat. What are you working on? Hey, Corey. How are you? You got that spot? They run it? Yeah. Okay, good. Tired. All right.
Hello.
Hi, Jake.
Hi. Does anybody have any questions? Anybody who's online? Do we have a quorum? I don't know if we're missing anybody.
Yeah.
Good. That's good. The problem with not knowing if we're missing anybody is that they can't speak up and tell me that they're missing. So let's give it one more minute, and then we'll just get started.
Oh, I don't. Can you hear me now?
Yes, I can hear you.
Oh, okay. I said I don't have any questions. I just see a very high learning curve. That's all.
Well, yeah. I mean, it's all new. It's all new, right?
Yeah, it's not like impossibly difficult. It's just, you got to remember this stuff or have little flashcards or.
Well, yeah. I mean, it's like it's like learning a new language.
It is.
It takes a lot of practice until you become fluent. But I mean, people learn new languages every day.
But not in one day. They learn it.
Not in one day. No.
So now, where are you located?
I live in New York City.
Oh, in New York City. I was talking to someone. I told them you were in Denver, Colorado.
Yeah, I mean, sometimes I am. I've got family out there. So.
Oh, okay. I don't know why I thought that.
But no, I live in the city, and then I come up to Syracuse from time to time. In particular for Hack Upstate. I used to live in Syracuse, so I've been coming up. I've been doing Hack Upstate ever since it was just just since I think the very first one.
So you come up for the hackathons?
Mm-hmm. Yeah. And yeah, it's nice to have that connection to the community,
Yeah. So we may see you in October.
Yeah, definitely. I had to miss this last one because I had some stuff I had to do in the city, but yeah, I'm gonna I try to come up. It's nice.
So do you work for a company down there, or do you have your own business?
I have my own business. I consult. Yeah.
What kind of problems do you work on?
Whatever people need. There's a large. Sorry?
I said that was a dumb question.
No, not at all. I mean, yeah, no, a lot of people.
I want to know the answer, Eva. It wasn't dumb at all.
No, I'm just still trying to figure out the whole like landscape, because to me this is the world, so everybody does.
Yeah. No, I mean, it's a great question. I mean, no, I mean, there certainly there are developers who specialize in a particular industry. And they, there are some developers who just, specialize in a single job. They'll get into one really good, stable position at a company and they'll just stay there for a long time. And then there are others who are, don't do something different. So yeah, for me, I like consulting because it lets me, go into different companies and solve a lot of different problems. And it's like very flexible. And so I've been doing that for, since 2013. So about 6 years now.
So when part of the problem is that when you guys talk about things, when I say, the teachers more, well, it's kind of hard to understand. Like when you say you go in and solve problems, like what sort of problems would people call you to come and solve for them? Well, and do they know that there's a tech fix for a problem? Because necessarily before that.
Yeah, so it's kind of like, so what I do is kind of like, people have an idea in mind for what they want to see built. And then the way you describe it is like, I specialize in custom like software development. Like I'll build custom business applications. So there'll be some client and they'll have a particular idea for some business problem that they want to solve, or maybe an app that they want to develop, or other things of that nature. But there's a particular problem that they a particular problem relevant to their business that they want to solve, and they have some idea of how that could be fixed using technology, in particular software development, sometimes hardware development, and then they through various channels that a connection is made, and we'll have a conversation about it, and to see if I can help them solve their problem. I know it sounds like very vague, but part of that is because like I work across industries, so the scope of the problems can be pretty wide for the type of work I might be doing. And then there's some stuff that I can talk about and some stuff that I can't, especially given that this is like live going out on YouTube right now, and it's going to get recorded for posterity. But I'm sure over the course of the course, we'll I'll have a chance to fill you in on some of the stuff that I've done, and talk about some professional stuff and some career stuff, things like that.
If you have a minute, I can shed a little bit of light on a real world that I'm actually working with. Do we have like a minute for me?
Yeah, let's do 1 minute, and then we'll get back to the exercises after that.
I'm going to keep it short and sweet.
Sure.
So I work for a human services agency, and part of what I do after I meet with my participants is I have to put in notes that can be shared with my program managers. And so in order for me to be able to do the notes to them electronically, someone had to give me a certain level of permission, and those permission levels had to be built in. The form field where they can even add me, they had to create some type of input and then assign me those levels. And then once they put me in, then they had to connect me to a back end database. And I'm assuming they're using different APIs and stuff where like all of these people are grouped. And so, they look at like where I am as an employee, and they say, oh, she can have access to this group. She can have access to that group. And then based on that, it also will tell me what type of notes I can put in. So there's different reports that I'm able to view and so on. So once I put in my notes, then the notes have to be approved. And then if I make a mistake on my note, and then it'll give me so much time. So there's a coding timer built in that says, if Dana wants to make a change in 3 days or less, she can do it without permission. But if it's more than 3 days, then she has to get approval from certain people. So it's so there are your if, then, do, while, can only do if you're on this level, that kind of stuff.
Yeah, that's all business logic that somebody wrote.
And they had to create, the program for that.
Yeah, that's absolutely. Yeah, somebody had that vision. They said we need this, this and this and this, and then they had a bunch of design meetings about it. And they wrote it all down, and then they gave it to a developer who created something, and then in the end they tested it out and they said, yeah, this seems like what we had in mind. And
it still has bugs from time to time that they have to fix. Like it crashed last week and someone had to go in and figure out why, and we were offline for 2 days.
Yeah, that software has bugs. I mean, it's the now I'm thinking about things I should have said during the bugs lecture. Well, maybe we'll return to that. Maybe the first 15 minutes of class is just from now on, it's just going to be about interesting and unusual bugs, and we'll just talk about them, because there's that's like, the great challenge of software development is how you is basically how you handle errors.
And just to add to what Eva was saying, I think that we get it when or what I hear her saying, and Eva, you can let me know if I'm right or wrong on this. It's one thing to teach us concepts, but we tend to make more of a connection when it's related to a real life or maybe real type business scenario.
Oh yeah, totally.
And I think right now, a lot of times when we, I'm not saying necessarily with you, but there is somewhat of a disconnect, and it makes it harder for us to wrap our minds around it. And that's why we say, well, when you do this, how would you use it? Where would you use it? Because that's not always explained to us.
Yeah, I get that. Yeah, it definitely helps to learn something if it's like, if you can relate to it through your real life experience. That helps to make it more concrete.
When we pair a new word, I have to attach it to like an idea I understand so that I can access it again. Otherwise, it's just floating around in there.
Like a mnemonic.
Not
Yeah.
knowing where to go. Well, a real world example is fine. Like when you were talking about the bank, like we're transferring money out and in.
Mhm.
Like, that was very easy to understand.
Yes,
Yeah.
that was good.
So
Yeah,
for
we
me-
need more. We need more of that.
Yeah, I hear you. Yeah, I've got a little bit of work to do on tomorrow's lecture content, and I've been trying to think about how to make it like very grounded. But I'm planning to iterate on that tomorrow a little bit before class. So I'll do that, and I'll try to take that feedback in mind.
Thank you. We appreciate it.
Yeah, definitely.
always helpful because you all of you developers, when I say you, I don't mean you personally, but
Sure.
all developers, you guys use a language all your own, like iterate through. Like I would never use that word to describe what you just described. So
Yeah. I
it just
mean,
helps, like to the extent when you're learning a language, you have to pair it with the language you already know. So
yeah, definitely. Yeah, at the same time, I think it's like a good, like it's a good idea, like when teaching, to use like technical language, or I mean, maybe it's good to explain it both ways, but like, because it's good because you're gonna get used to, yeah, you got to learn the language. So, should we do some exercises?
Sure.
Okay, let's dive in. Oh, sorry, is that Anna?
Hello?
Hello.
Oh.
Just making sure. I can hear you.
Hey, Anna, we're just getting started. You didn't miss anything.
All right.
Okay. So yeah, to start out, so there's this particular activity that some developers do from time to time, called golf, which is where you try to write the tiniest possible program to perform a particular task. And regular expression golf, or regex golf, is you try to write the tiniest regular expression possible to match a particular pattern. So we're gonna try to do this for these strings right here, strings 1 through 7. Car and cat, pop and prop, ferret, ferry, and Ferrari. Any word ending in IOUS, a white space character followed by a period, comma, colon, or semicolon, a word longer than 6 letters, and a word without the letter E, little e, or capital E. And we have a little bit of sample code to get us started with this, which I'll just paste into the REPL right here. Okay. So you can see that the verify function, source regexp. I mean, yeah, this is good. Okay. So you can see what the verify function is doing. It's taking the regular expression. So it's taking 3 parameters. The first one's the regular expression. And then the second one are strings that you want to match. And then the third one are strings that you do not want to match. And it's going to go through and it's going to check to make sure that we've actually completed the regular expression. If we haven't, if it's just got these 3 dots, it means it's going to ignore it. And then it goes through for each of the strings that we want to match, and checks that what we've written will match the string. And likewise, it'll go through all the strings that we don't want to match and make sure that we're actually not matching that string. So would anybody like to take a shot at the first one? So it's, actually, we gotta go in and figure out what it is. Okay, so the first one is car and cat. So we want an expression that's gonna match car and cat, but not camper or art? Who would like to take a crack at this one?
I mean, kind of.
So it's like the bad one we did, right? Bad and badly.
Yeah, yeah. And so there's yeah, so we want car and cat. So yeah, I mean, there are a couple of different solutions to this. I mean, that's the whole idea behind like golf, regex golf, is that there are a lot of different solutions and we're trying to find like the smallest one. But
Okay.
to get started, you could just use anything that makes sense.
So should we use the console log to start?
Yeah, if you want to, or you can just I mean, you could work however you like. I mean, to start though, you're gonna replace right here this call to verify. This is the regular expression part. This is the part that you're gonna replace with the regular expression. So that's where you're gonna put it.
So we're supposed to be typing this ourselves, or?
Yeah. You can dive right in. I mean, I'm assuming that you've joined the REPL.IT session.
I still need to join that. I'll do that now.
Yeah, that'd be good, because then you can everybody can participate, which would be a nice thing.
Huh.
Does anybody want to take a shot at this? How would we get started? Does anybody have a sense of how we get started?
Let's see. See. Okay. So for the first one, what is it that we're trying to do again?
You're trying to match car or cat. I'll just write it up above here.
Trying to match car or cat.
Yeah, car or cat. So the first array here are strings that we want to match. And then the second array are strings that we don't want to match. So we want to match the string my car and bad cats, but we don't want to match camper or high art.
Oh gosh. So, oh gosh. So are we using the train of thought that we want to match sets of characters?
Well, I mean, there are different ways to do it, right?
Okay.
So we've seen a couple of things that might be useful.
Okay.
Right? So we saw, a pipe character, which lets you say this guy or this guy, right? So that might be one way to get started. But then we've also seen, sets of characters, right? So you can also write out part of it, the parts that are in common, and then the parts that are not common. You could use a set operator to match those parts, and that would probably be a bit smaller. And so there are a couple of different ways to go about it.
Well, couldn't we just do \CA and then paren R and then paren T?
Yeah, that's very close. Do you want to type that out and we can take a look at it?
Wait a minute.
Okay.
Yeah.
If I heard it correctly, I'm thinking
Yeah, it wasn't actually on
that was
REPL yet.
missing was the outer parentheses for the group.
Yeah, you could use grouping for this. Yeah, that might be a way to do. Yeah, you could definitely use grouping for this. So let's just trim this down a little bit. Okay, so so this is so this is a good start. This is, however, going to match the expression cart, because it says I need a C, and then I need one A, and then I need one R, and then I need one T.
You got to get rid of the R.
Well, if you put the R in parentheses and then do the or.
Yeah, that sounds like it might work. Would you like to make that modification?
Yeah. Yeah, put the R in parentheses. So that should just be C.
Wait, and then I just put a pipe in.
Yep.
Okay. I don't know if that's right, but I wasn't sure if you saw it.
I mean, that sounds right. Could definitely use a pipe.
I took notes, but I can't find them right now. So. Of course.
Okay, cool.
I don't know if you need spaces.
Yeah, that's looking good. Okay, let's try to run this. This looks like it'll probably work.
Which slide is this? I'm looking for the slide that would have talked about the method that we're using now.
Oh, well, so there's the slide that's about the pipe. If you just like search for pipe, like do find pipe, you can find the part about the pipe. Okay. And let's see here. It looks like there's a syntax error. To figure out why. One moment, please.
It's not doing anything.
Line 42. Oh, needs that. Okay. Okay, it looks like it matched high art, which is actually a little bit surprising to me. Because I thought it would need the CAR, but oh, I know. I think I know why. Okay, so the pipe is a little bit tricky.
Yeah, that's actually in the slide that says choice patterns. That's
yeah.
what I'm looking at.
When I use the pipe, I like to be extra careful about, I like to use like extra parentheses because it can be a little tricky, because I think what this is doing is the pipe is saying everything to the left over here is one choice and everything to the right is another choice. And I think the reason why it's matching high art is because it's trying to, like, it's matching the T. And I believe that we can, actually, this isn't set up to tell me what we're matching. But anyway, I think that's what's happening here.
So it doesn't match it up in order? So it's not cats or car.
Well, what I'm saying is that, like, because of the pipe, I think like everything on the left here, like CAR, it's interpreting as one option, and everything to the right, it's interpreting as the other option. No, art is, we don't want to match on art. We explicitly don't want to match on art. But I believe that we can solve this with just one modification, which is if we do it like this, then this will probably work. Yeah, it didn't give us any output, so that means that it succeeded. So, and I think that's also I think that's also the smallest. I'm trying to think if there's a smaller version that we could do for that. No, I think that's it. I think that's the smallest version. Let's move on to the next one.
So wait, sorry, what did you just do? Did you just add that
Right.
backslash?
What I did was, yeah, let me show you. Okay, so basically I took away the parenthesis from the R, and I took away the parenthesis, like to the right of the R, and I took away the parenthesis from the left of the T, so that I put them into one parenthesis. And what that meant basically is that it has to look for a C and look for exactly one A,
Okay.
and then look for an R or a T.
Gotcha. I was looking at the wrong screen or the wrong. Never mind. I was just wrong.
So we can, let's move on to the next guy. Okay. So, so for this one, we wanted to match pop and prop. So what would be, so you can see here we want to match pop culture and mad props, but not plop or prop. So what would be like a good concept that we could use for this? Like what regular expression construct might help us here?
Can you use a question mark?
Yeah, that would be a really good way to do it. So would you like to take a crack at writing this regular expression?
Sure.
Okay, great. That looks good. Do you want to try to run it? Okay, it didn't give us any output, which means that we succeeded. I think that the fact that it doesn't give us any output is a little bit unsatisfying, but anyway, that means that we succeeded. All right, let's move on to the next one. Very nice. Okay, so we wanted to, for this one, we want to match ferret, ferry, and Ferrari. As in ferret, ferry, and Ferrari, but not ferrum or transfer. What would be, so that, yeah, there are a couple of ways to do this one as well. Would anybody like to take a shot at this one? Maybe just to get started, then we can start to, do a first pass and we can start to reason about it. Cool. Okay, all right, that's a good start. So yeah, so you've identified that all of these guys start with FERR. And the question is then, how do we deal with the remaining letters? And do you think that you could use the like the technique from the first regular expression that we wrote, the one that's car and cat, in order to maybe manage, like to deal with the differences between these different words? Like you could use that same technique with the pipe. Or you could use sets as well in order to do this.
Oh. So in sets, you want to match your strings or your digits.
Yeah, so the sets were when we were using the square brackets. And the set basically says, I want to match exactly one character for anything that's in this particular set.
Okay.
Oh, interesting. Yeah, I think that actually might work. You want to run it?
I'll try.
Okay.
That was I winged it. Wing it. I don't know what.
I think it's winged.
Past tense. Wing.
Okay. Yeah, it looks like that succeeded. Very nice. Very nice.
I do have a question. Is
Shoot.
there a way to like say, because we want like the shortest way, right? Like the most concise way. Is there a way to say just like not or trans?
Not
For like the bottom, like we want to return everything that doesn't have as a suffix or trans as a prefix. Basically.
Oh, I see.
You see what I'm saying? Like for the most concise way to do it. Or is that not a thing?
Well, you don't need that to fulfill what has been written here, but like I see what you're asking. So
like in another scenario, writing 2 bars might be like excessive, where you could just write something else.
Like if we basically you're saying if we had a scenario where it was like ferret and we didn't want to match on the word ferret, but we wanted to match the word ferret.
Right.
Okay. So yes, the way that you do that is through set inversion. So I'm going to run this to show that it fails. Okay, failed. So basically, here's how you do it. So remember that caret?
Oh yeah.
Inversion. So basically everything. Okay, so there are two ways. There are 2 ways to do this. All right. The first one is you do not if you just don't want to match ferret, right? But then it's not going to match any of these guys that we want to match. The reason why is because it expects
an E in
one. No, not an E. It expects a character.
Oh, okay.
Just any character that's not an E. So if you have, ferret, ferry, or Ferrari, there's no character that precedes it, right? So it won't match it. So we would actually have to write, a question mark there to make it optional.
Okay.
Yeah, I'm pretty sure. Well, actually, no, then it probably still will match ferret. Yeah, no, it matched ferret. Okay, so that part actually doesn't work. So we don't want, there's another way to do it. It really depends on what you want. The other way to do it is if we only want to match the word if it begins at like the start of a line, so it doesn't have any preceding characters before it. The way that you can do that is you write a caret at the beginning, and that means only match things that are at the beginning of the string. So this will work. But if I wrote a Ferrari, then that doesn't work because it's not, the word Ferrari isn't at the beginning of the string. Okay, one more example. The other way you can do it is with \b. So \b means word boundary, and word boundary is basically anything that shows that like you've reached the end of a word. So that means the start and end of a line. That means any white space, any punctuation, like basically things that mean this word is done. And so this will work. Yeah, so that works. So that's probably the best way to do it. This is a good question.
Thanks.
Okay, let's do the next one.
iOS.
Okay, yeah, any word ending in IOUS. Okay, as in delicious or spacious room, but not ruinous or consciousness. Would anybody like to give this one a try? This one is a little more nuanced, and you'll have to use a different concept because it has to come at the end of a word.
Dollar sign.
So, so we've seen some stuff so far that will help us. Like for example, how do you know that you are at the end of a word? Like this is something that we just looked at.
That there's a space.
Well, yeah, but with a regular expression, how do you tell the regular expression that you want
to? Would you use a dollar sign for like end of input? Or no, is that like?
Well, no, actually, you're on the right track. Yes, so that means that you've reached the end of the line,
right? Like,
but it wouldn't match this spacious room example.
Right.
But
the border thing, the /B, or
right, exactly. Yeah. So
yeah.
so it seems like the solution is going to use that special word boundary character. So maybe we could start to write our solution out right now. Yeah, does anybody want to take a crack at that? Maybe somebody who hasn't hasn't gone yet. Yeah, great. Yep, that's looking good. And what about the yeah? Nice. Okay, cool. Let's maybe just try to run that and see if it works. You want to run it? Okay, it succeeded. Very nice.
Yay.
Yay. All right.
Yay.
Let's go on to the next one. Okay. A white space character followed by a period, comma, colon, or semicolon. Okay. All right. So here, let's break it down. How do you find a white space character?
/W.
Well, it wasn't /W.
S.
Yeah. There's got to be a backslash though.
Yeah.
And then how do you find period, comma, colon, or semicolon?
There's a special character one.
There, I can't remember if there is one for punctuation, but because I can't remember, let's not use it. Let's do it the other way. So we've seen one way to do or, right, which is the pipe. But because the pipe is pretty powerful, it means that we can like say this sequence of characters or this sequence of characters. But here we only need to match one character.
Would you just put the period there after the S?
Well, you need to be able to match a period or a comma or a colon or a semicolon.
Oh, you want us to write it for the whole thing. So you could do period. No, I don't know. Wait, hold on a second.
Is there a limit to the number of pipes you can use? Can you just like pipe as many things as you want to pipe?
Yes, you can. But we've used pipe a couple of times now.
That's true.
And so there's another way to do it using a technique that we haven't used yet.
Would you use brackets?
Yeah. You can use brackets for this.
So, and you can just type them like right next to each other, correct or no?
Totally, yeah.
Okay, so like that?
Mm-hmm.
Did I miss one?
Period, comma.
Oh, I didn't do comma.
Needs the comma, yeah. Yeah, and make sure you remove the ... before. Yep, okay, try to run it. Okay, that worked. Now, there's one other reason why I wanted to use angle brackets, or not angle brackets, square brackets here, and not use the pipe. And the reason, I'll just show it to you. The reason is that, okay, so of course the other way we could have done it is like this, comma, colon, semicolon. But there's a very bad bug in this. Does anybody see what it is?
Is it
that you use a comma after your verify?
Nope, the comma's okay. Comma's just a comma in regular expressions. But but there's something else. So, sorry, go ahead.
No, it's okay. I thought it was maybe the period.
Yeah, it is the period.
Oh.
So, yeah, so the period.
Go ahead.
So the period is a special character, and it means match any character. So if we ran this, it would match bad punctuation. It would basically match the P, because the period, matches the P. So
after that white space after bad, you're saying?
Yeah, exactly. Oh, sorry. This was actually, we wanted this to match, but it would match this T here, this
right.
space, and then the T. So the way that we could work around that is by adding a backslash.
As a special character, kind of.
Yep. And that escapes the period, and then it's just a period. But of course, it's, but if you put it inside of square brackets, then it's just a period.
Makes sense.
Okay. So let's do the next one. We're getting pretty close to wrapping these guys up. A word longer than 6 letters. Oh, okay. So what do you need to do for this one? How do you first of all, how do you specify greater, like the notion of greater than 6 letters? Let's say you just wanted to match the letter A.
Mm-hmm.
such that it was a sequence of A's that's 7 or more letters.
X plus something.
That is a good guess, but that's not it, because plus just means 1 or more.
There's one for like at least, right?
Correct.
But I don't know which one it is.
Anybody remember? We haven't used it yet.
Is it the curly braces?
Yeah, exactly.
Ooh, good job.
Very nice. So yeah, you could use the curly braces, and then how do you do any character?
Backslash lowercase w.
Yeah, that's probably a good way to do it. I was thinking period, but actually, no, yours is more correct, because period would match white space, which is actually not what you want. So yeah. Does anybody want to write that out?
Somebody doing it?
I don't think so.
I like can't tell, it's so delayed.
Yeah, it is not the fastest, but
Yeah, before every time I need to see something new in my Reply, I have to refresh my screen.
is that right?
Yeah.
Oh, okay, that's good to know. What browser?
Clicking on the
I'm in Chrome, Google
Okay.
Chrome.
Dana,
Yeah.
have you tried clicking on the white portion? It just like refreshes by itself after people type usually. When you
I realized that, because I'm switching back and forth between Reply and the video stream.
Oh, okay.
And it's not doing it. It's sometimes when I look at my Reply screen, none of the updates from the live stream are there, and when I refresh it, then they pop in. Yeah. So, and then what is this? Yeah. Then there's on the right side of the screen where it says node v10 15.2. That is just, it's like it's continually trying to load something, but nothing ever appears on that side. So, yeah.
So we have a minimum of 6. Do we need to make the maximum six too?
No, it just says any word longer than 6.
Longer than 6. Okay.
Yeah. So I think you're going to want to put 7. And so that means, so what this means, what's written here, it means that you're going to match, any alphanumeric. Yeah, there you go. That's what you need. Very nice. Do you want to try to run it? There's a syntax error. Where's the syntax error?
I think it's that comma after the backslash.
Yeah. Oh, no. That was good.
No, this one. Yeah, I mean, backslash, it's 7 curly brace backslash.
This comma, the comma's good. The paren needs to go.
Oh, I see.
There you go. Cool.
I'm just going to try to reload my browser, so I'm going to disappear for a moment.
Okay, and I can try to help you debug this, or maybe our TA can help as well.
I'm just going to try to reload, and then what I'll do, I think for tomorrow, what I'll do is I'll just, I have an adapter where I can plug hardwire to my internet and see if that makes a difference. Instead of being on the Wi-Fi. But I noticed the same problem last night in class, so I don't think that's it, but I mean, it wouldn't hurt to try.
Okay.
All right, okay. All right, back in a few.
Okay. Are you still in the video though?
Let me close that.
Maybe keep the video open, because then we'll just. we'll just keep going, and then you can just reload REPL.
Yeah, I'm still there. Okay, go ahead.
Okay, cool. All right. Okay, last one. We're pretty close. Pretty close. All right. All right. A word without the letter little e or big E. So, so we do want to match red platypus and wobbling nest. But we, wait a minute. We don't want to match earth bed, learning ape, or beat. Wait, I'm confused. A word with, we want to match, oh, I see. Okay. So we want to match if there is a word that does not have a letter E. So there needs to be at least one word without the letter E. So in the second example, all of the words have the letter E. And in these first examples, there's one word which does not have the letter E. Okay. So the question is, how do you specify that you do not want to match something?
Caret.
Correct. So yeah. So I think we have everything that we need, right? Does anybody want to take the caret example and see if we? I think it's still up there. Oh, I guess I got rid of it. Does anybody want to try writing completing this example using the square bracket caret notation? Yeah, that's looking good. And then it needs to be a word, right? So how do we specify that it's a word? Oh, no, you don't need that. It was the how do you, so basically you want word boundaries, right? So how do you specify word boundaries?
\B, right?
Yeah. But you want to do it not inside of the square brackets. Yep. And you also don't need 2 backslashes because we're inside of a regular expression. If it was a string, then you would use 2 backslashes, but you just need 1. Okay, that's looking good. So now this thing is going to match words that do not have the letter E that are only 1 character long. So it would match the word A and the word I, but it wouldn't match any other. So we need to add one more thing to it, right? Which is we have to make sure that it's, at least 1 character long, but potentially longer. How do you do that? IDK.
Star.
It wasn't the star. It was a different one.
I don't know if that's
Yeah,
right.
yeah. That's, you could write it that way. There's a shorter way to write that.
Okay, I'll get rid of that.
It wasn't the star. It was one of the other ones. Which one was it? 1 or more.
1 or more.
X plus.
Well,
Yeah, that's right. The plus. Just 1 plus. Yep. Good. And I think that should work. Does anybody want to run it? Unexpected match for earth bed. Well, I guess I was wrong. Okay, just a moment. Let me figure this out. Why didn't it? Word boundary. Anything that's not an E. What is it matching there?
Does it have to do with the fact that both of those words have E's, like both in each string have E's in them? Because it didn't match beat.
That's true. It didn't match beat. That's a good point, because then you've got an E followed by another E. On the other hand, it might be matching the white space character, like the space character. Let's go in and add a little bit. Let's go in and capture the regex. M equals regex dot exec.
And that's not refreshing on its own to show me what the other students are typing. And then on the black screen where it is supposed to be showing me.
So is your REPL.it not working?
You talking to me?
Yeah.
Oh, I'm sorry. I thought I was on mute. I'm actually talking to Dave and Hat.
Oh, okay.
Well, okay, I'll put myself on mute.
I can try to help debug it as well a bit later. But
all right, no problem.
Okay. But yeah, so that was correct. It was matching the space, the white space. So what I was expecting in the word, like the word boundaries, it wasn't. That wasn't sufficient. So potentially, what we have to do is, I think, if we just add a space to the set of things that we don't want to match, I think that should work. Let's try. Yeah, okay, so that worked.
Oh, okay.
Okay, cool. We did we finished our round of golf. So we have 15 minutes left. I do have some other exercises. Should we keep going? Does anybody have any questions right now?
I do have one question.
Yeah.
Why do you, on our last example, why do we have to have the /b twice?
Oh, okay. That means start and end word boundary. So basically it means the start of the word and the end of the word.
Okay.
Yep. Okay. Let's do one more exercise. Okay. Quoting style. Imagine you have written a story and used single quotation marks throughout to mark pieces of dialogue. Now you want to replace all the dialogue quotes with double quotes while keeping the single quotes used in contractions like aren't. Think of a pattern that distinguishes these two kinds of quote usage, and craft a call to the replace method that does the proper replacement. So, so for example, for some text that says, "I'm the cook," he said, "it's my job." You can see that it's using single quotes. For contractions, and then also for text that should be in double quotes. And we want to go through and write, change this regular expression here so that it changes the single quotes to double quotes. So this one's, a little trickier.
So it's just the space. There's a space before or after the double quotes. No.
Yeah.
Before, no, because there's double quotes. Wait.
So you want to replace the single quotes with double quotes, but you don't want to replace the single quotes when they're used in contractions.
Okay, so if the single quote has letters on either side, then it should stay. And if it has a quotation mark, I can't see the limit. All right.
Yeah, you're right.
If it has a quotation mark before or after, it should come out. Well, I mean, just if it doesn't have a letter right in front of it.
Well,
or after.
remember, so you're on the right track. So remember that, so just about the quotation mark part, remember that you don't actually get the double quotes. Like these double quotes are used to declare a string. So they aren't actually in the string.
Oh, right.
What about,
Oh, okay.
can you use, like, if it's at the beginning or end of because like
Yeah,
you
if
wouldn't,
there's white space in front of it. Sorry. If there's, I'm sorry, I was just thinking out loud, but if there's white space in front of the single quotation mark or after the single quotation mark instead of a letter, then it can come out and be replaced with the double quotation marks.
Yeah, although you can see for the first and last single quote characters that there's not going to be white space there, but maybe if you use the word boundary, then
Right.
that might work. On the other hand, it's not clear to me that that actually will work, because I mean, I think it will work for, I'm not sure if that would work for the case of the contractions, because I think that a parenthesis might be considered a word boundary. In which case, because I think punctuation is considered a word boundary character. So I'm not sure if word boundary would actually work. But I think you were on the right track before about checking to see if it's like the contractions are basically, the way to identify the contractions is to see if they're
Right. So if it's not, if there's not or a letter before or after it, then we should replace it.
Yeah, that sounds right. Sorry, what were you saying?
one of them has a comma before it, not a letter.
Yes, that's true.
But that has to come out. Yeah.
It doesn't have to, but
but that would be replaced with double quotation marks. Because so if we define the,
I'm just saying, like, we have to be careful how we define it. That's all.
right.
True.
Could you say the beginning? Also, could you do like the beginning or end of an input? Does that work or no?
Yeah, although I think that if you just handle the case of contractions, then that should be sufficient. I think to handle all of the, like, basically if you know, I think you can like replace all of the quotes that aren't in contractions. So if you can identify the contractions and say not contraction, then I think you can replace all of the other quotes.
Yeah, so not preceded or followed by a letter.
Yeah. So how do you so how do you write that regular? So let's work on that regular expression. Quote that's not preceded by or followed by a letter.
We need a backslash. Just kidding. Hold on.
That's an excellent question, Jake.
There is actually there are at least two ways to do this, right? So you're going to want to go back to well, I mean, I'll let you guys work on it for a minute, and then I'll join back in.
Do we want to use the match again?
You can actually do it with text.replace. You just need to change the regular expression, and you need to change the thing that you're the replacement character. Yeah.
Oops. Who did that? That was me, right?
So how do you specify?
Couldn't you say like use the W for the alphanumeric character? Like if it like saying it doesn't have one of those?
Right. So that's, again, you're on the right track. So you need, so remember there's a special, instead of \W for matching alphanumeric characters, how do you specify the inversion of that?
Caret.
Caret.
Yes, normally you could do caret with a character sequence, but there's actually another special syntax.
Lowercase s.
Oh, no, that's for matching white space.
Oh, wait.
So,
Capital W.
This any character.
yes, yeah, no, you got it. Capital W.
Oh, capital W. Okay.
Yeah, yeah. Capital W is the inversion. Yep. And it means everything that's not an alphanumeric character. Just like \S meant everything that's not white space, and \D means everything that's not a digit. The capital indicates that it's the inversion of the of that special set. So so let's use that now to basically match all of the quotes that are not preceded by or followed by, well, actually, and are not preceded by and followed by a alpha character. Anybody want to write it? Let's finish strong.
So we wanted the capital W, right?
Oh, you got to put it in the regex, which is in the backslash. Yeah. Sorry, in the forward slashes. Yeah, where the A is.
Save the day, Caitlin, go do it.
Me?
Yeah, you're right there. You're doing
Okay,
it.
go
Wait,
for it.
I saw you doing it.
Go for it. Go for it.
One more time. It's
Okay.
Capital W.
Yeah. Backslash capital W.
Okay.
Mm-hmm. There.
Yep.
Okay.
And then
Anything. So anything that's, so if it's near anything that's not a special character, or that's not a alphanumeric character,
yep. So that \W it does that for you.
right?
And then you've got, so
And there's the preceding part.
you got the quote, right?
Wait, what? I'm lost now.
And then another W. Whoa, whoops.
And then, so instead of double quote, it needs to be single quote.
Oh, okay, never mind. I see.
And then you just go over, okay, so that's looking good. And then we want to replace that. Well, okay. So this gets a little advanced, right? Because we want to replace, well, let's see, we've got 3 minutes left. So we got to use, okay, let's do it like this.
What happens if we run it?
Yeah, go for it. Let's run it and see what it does. Okay. So yeah. So we're replacing that quote with the letter B, right?
Oh.
So we want to we want to go in and change that to double quote, right? So you got to do / double quote. Yeah.
Oh, what just
Yeah.
happened?
Now write another quote there. Yeah.
I did.
No, I know it's the editor. It's trying to be clever. Okay. You can try to run it again.
I was like, oh, yeah, I did do that.
Yeah. Okay. So that's starting to look good, but we can see that it did a couple of things which we didn't want.
Right.
So, okay. So
Yeah.
Okay. Well, I mean, that's a start.
Okay. There's that.
Okay, cool. So it's starting to get there, right? Okay. So it didn't match the first, the quote in the contraction. Good. That's expected. It did match the quote in the, the second quote, which is good. But it failed to replace the first single quote and the second single quote and the last single quote. So
It took out a comma.
Yeah, it took out the comma after cook too.
oh yes, it did that too. So basically the characters before and after. So anyway, we have 1 minute left. The solution involves using grouping, like parenthesis groups, and the other thing that you have to keep in mind is that, like, you may not always have a character before the quote, right? Sometimes you're going to be at the start and end of a line. So anyway, if you like, we can make this an exercise to do that you guys can work on your own, and then we can pick this up again in the first 5 minutes of class tomorrow morning, and try to resolve it.
Okay.
Sounds good.
Okay. All right. Does anybody have any last minute questions before we sign off?
Nope. No.
Okay, great. Okay. Thanks a lot, everybody.
Thank you. Good night.
Bye. Good night. Bye.
Bye.